Garcia. Today I am reviewing GCF and LCM. GCF stands for greatest common factor and LCM stands for least common multiple. For you to understand these two concepts, you need to understand the terminology. So factors are the numbers that when multiplied together obtain a multiple. In this example, you have a list of factors and together combined, I made a rainbow. When you combine them, 4 times 6, it equals 24. 3 times 8 equals 24. So these factors, when multiplied together, produce a multiple. So that is the terminology associated with GCF and LCM. Some of you oftentimes ask me, how is this applicable to modern life? So here is the office. I work at Dunder Mifflin Inc. And your name is Jim. If I can get Jim. So Jim takes his break every 45 minutes and Pam takes her break every 20 minutes. So we have Dwight here. Dwight wants to know when they will meet again so he can spy on them. So if you utilize LCM, you will figure out at what time they will together have their break at the same time, of which would be within 3 hours. So you would utilize LCM to figure out their meeting ground. Another example of how you would use GCF or LCM would be with GCF, if you have many individuals and you need to form a team, you would use GCF to figure out how many teams you would need. For example, in my class, this is a simple example, but I have 20, let's say I have 25 students and I want to make 5 table groups. I would use GCF to find the greatest common factor, and that would be 5. So I would know that I would need 5 to a table. Here is the visual that I provided on Class Dojo yesterday. Let me go over it a little more. So here are my two multiples. This is 16 versus 24, and I'm trying to find the GCF. So I'm going to use the standard practice of factoring out these numbers. I think you're more familiar with this. So to factor out 16, I think of the factors that multiply together to form 16. I can do 4 times 4, or I can do 8 times 2. In this case, I chose 8 times 2. 8 times 2. Now I'm going to observe these two numbers. I'm going to look at number 2. Number 2 is prime, so I can no longer factor out number 2. It stands alone. But 8, I can still factor out 8. So 4 times 2 makes 8. So I just factored it out. You're going to continue to factor out these numbers until you find the prime numbers that can just stand alone. Remember, prime numbers are numbers that only multiply by themselves and 1, and you can't do much more with them. So there's a standard list of prime numbers, and the rest are composite. Composite numbers, you can factor them out because 2 other digits multiply to obtain that number. That is not 1 in itself. So in this case, I have factored out my 16 and I've factored out my 24. And I've circled or underlined the numbers that are prime numbers that stand alone. Once I've obtained all my prime numbers, I'm going to compare this list to this list. And then I'm going to find the common ground. In this list, I have 4 2s, but in this list, I have 3 2s. So they have 3 2s in common. That's why I circled the 3 2s. So aside from that, that's it. That's all they have in common. There's no 3 over here, so I can't multiply the 3 later on. So in this case, it's 3 2s. I can do 2 cubed, or I could multiply 2 times 2 times 2 to obtain 8. The greatest common factor between 16 and 24 is 8, and that is how I obtained the greatest common factor. So hopefully these steps helped you out, or this video. If this sounds too complicated, yesterday I learned a different method of which we didn't discuss. Here's another method that I learned of just recently, and I thought it was magical because remember in our class, math was magic. So I'm going to continue with the same example, 16 versus 24, and create somewhat of an upside down tiered cake. So here's 16 and here's 24, and what you should do is line them up on a line and put like a little L here. Okay, so capture or catch the numbers with an L. So what you're going to do first, after you've done that, is compare the two numbers and start with the number 2. If they're even, start with 2. If they're odd, start with the number 3. And you're going to decide whether they have the number in common. They can divide by that number. So 2 and 16, 2 and 24. I can divide 16 into 24, and I can divide 24 into 2. So when I do that, I obtain 8 and 12. So 8 times 2 equals 16, and 12 times 2 equals 24. So what I'm going to do is put those two numbers underneath here. And I'm going to do that same L. And then I'm going to compare 8 times 12. So 8 and 12 are even numbers, so I know that I can divide them by 2 again. So I'm going to put that 2 out here, and I'm going to go 8 divided by 2 is 4, and 12 divided by 2 is 6. And then I'm going to, again, catch the numbers and create this sort of L. And then I'm going to compare 4 and 6. 4 and 6 are still even, so I can divide them by 2 as well. So 2 divided by 4 is 2, and 6 divided by 2 is 3. So once I get to the bottom tier, and I've made that L and I've captured those two numbers, I look at 2 versus 3. 2 and 3 don't have much in common, and they are also prime numbers. So I stop right here because I can't split them up anymore. And now what I'm going to do for GCF is I'm just going to look at the side. I'm going to circle these numbers on the side, and I'm going to multiply them together, and you will find math magic, because basically 2 times 2 times 2.
While I'm on this image, you can also use this example 16 versus 24 to find LCM. All you would have to do instead, and let me see if I can do it with a marker, is create an L. So you'd use these numbers, and you would also use the bottom two numbers that it ended with, and then you would multiply these numbers together to find LCM. Notice the L kind of helps you out and guides you. So the LCM for this example, 16 versus 24, would be 2 times 2, which is 4, times 2, which is 8, times 2 is 16, 16 times 3. So 16 times 3, so 16 times 3 would be 48. The LCM, greatest common multiple, would be 48. So let me actually go over LCM some more. Here's the visual that I provided for you on Class Dojo yesterday. In finding LCM. This is the traditional method that we tend to use to find LCM. What you do is you line up your two numbers that you are comparing. Here I'm comparing 10 versus 8. And what you do is you use your factors, multiply them together, and these are the multiples that you obtain. So 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5. Same with the number above. 10 times 1, 10 times 2, 10 times 3, 10 times 4. You can continue going, but in this case, in these two examples, what happens is you're finding the least common multiple. So once you've found a number that they have in common, you can stop then and there. So in this case, it's 40. The correct answer would be 40 for the least common multiple of 10 and 8. Now, as far as the cake tier that I was showing you, it also comes in handy. It's the same method that I used previously for GCF. So let me show you what I did here. You'll end up with the same product. So you're going to compare 10 and 8. And you think of the prime number that divides into both numbers. So in this case, it's 2. They're both even. So I know to go to my lucky number 2. So 10 divided by 2 is 5. 8 divided by 2 is 4. And basically what ends up happening is 5 and 4 don't really associate with one another. 5 is prime, so you can just stop right there. 4 can be split up some more, but it doesn't have a number in common that would split with 5. So in this case, you are left with 2 on the outside, 5, and 4 on the bottom tier. For doing the cake piece, you're going to create an L for LCM, and you're going to multiply these together. 2 times 5 is 10. 10 times 4 is 40. You obtain the same answer as you would do the traditional method, as you would be doing the traditional method. So it's kind of cool to use this new style versus this one. This one right here, you could also find the GCF. So like I said earlier, if you use this cake method, it might be better because you can find both items in just one try. So in this case, if I wanted to find the GCF of 10 and 8, all I have to do is look on the side right here, not these two bottom numbers, and my GCF would be 2. And I could prove that by doing the traditional method. So let me flip this over to prove it to you. So if I claim that the GCF is 2, let me use that factor tree again. So it was 10 versus 8. So 5 times 2 equals 10. These are prime numbers. So I'm going to circle them or underline them. In this case, 4 times 2 would make 8. 2 is a prime number. I'm going to circle it, and 4 can be divided some more. So 2 times 2. I'm going to circle 2, the 2 and the 2. So in this example, I'm going to compare the numbers that resulted from factoring out the number. And here I have a 5, but I don't have a 5 over here, so I'm going to ignore the 5. Here I have a 2, and I have 3 2s over here, but since I only have these 2 in common, the GCF in this case would be 2, as was mentioned on the cake as well. Sorry, guys. Did I mention I only taught history previously? So I have never taught math. So yeah, here's the 2.
Now that I've gone over reviewing GCF and LCM with you, I would like for you to practice that new method that I taught you that looks somewhat like an upside down cake. So here are the 2 numbers that I would like for you to review. It's 20 and 22. I would like for you to find the GCF and the LCM. So I hope to see your examples. If you could please take a snapshot picture of your example of how you found 20 and 22, GCF, LCM. Dwight and I will be waiting for it. Thank you.